Hey everyone, so I thought I'd spend a little time going over the practice exam key for practice exam 1, fall 2026. All right, so yeah, the exam will have, it's really more like a mini exam because it's just 15 questions or so. Yeah, 10 multiple choice questions, 5 points each, and then 5 free response questions, 10 point each, adding up to 100. Okay, so number one, convert .001 into scientific notation. If you look at the decimal point, it's over there. We can move it 1, 2, 3 times so that the decimal point is to the right of 1. And since we are putting a number smaller than 1 into scientific notation, we're going to, anything that's like, a number that's expressed as a decimal, 0.1, 0.01, point anything really, you're going to be having a negative exponent as your power of 10. So we moved the decimal point 3 times, so it's going to be 1 times 10 to the negative 3. Okay. Now we have, for number 2, a number that is 1 or greater. So that means we're going to have scientific notation being used, having a power of 10 that is going to have a positive exponent. Okay, if you have a number bigger than 1, you're going to need a positive exponent in your power of 10. So we can imagine a decimal point being to the right of all the zeros. We're going to keep moving it until it's right next to that 1. So we go 1, 2, 3, and commas are convenient because you helps you count in threes. 4, 5. We moved it 5 times, so it's 1 times 10 to the positive 5th power. Convert 7.9 times 10 to the 2nd power into a standard number. Well, 10 to the 2nd power, that's going to be a power of 10 that will result in us having a bigger number. In other words, we're going to move our decimal point to the right. So 7.9, we move it 1 time, we move it 2 times. We'll have to insert a 0 after the 9 because there is no digit there originally, so we get 790. Okay. Great piece of advice I'll give you right now is if you're not sure of any of these conversions, just type things into your calculator to see if you get the correct conversion. Like you could type 7.9 times 10 to the 2 in your calculator. You'll see if you got 790 or not. All right, 32.1 times 10 to the minus 4. We're going to move the decimal point 4 times, but 10 to the minus 4 means we're going to end up with a smaller number because of the negative exponent. In other words, we need to move that decimal point to the left. So we're going to move it 4 times. That's going to create 2 zeros that we need as placeholders. Okay. That 0 in front there doesn't really matter. That's what I call a cosmetic 0 because it's just there for appearance. It doesn't change the value. Okay. Same question as last time, except put into scientific notation. So again, like I talked about in class or videos, scientific notation means it's going to be a number between 1 and 10, or just under 10. It can't be 10 itself. So 32.1 times 10 to the minus 4 looks like scientific notation, but it's not. 32.1 is the same as 3.21 times 10 to the 1 power. Okay. And so I could like break 32.1 apart. Let me do that on this separate screen. 1 second. Okay, so 32.1 times 10 to the minus 4. Okay, this part that I'm going to underline right here, we could rewrite this as 3.21 times 10 to the 1 power. You just leave it as 10, 10 to the 1 power, whatever makes more sense to you. All right, so I'm left with this. When it comes to powers of 10, if you have them next to each other, you can just add up the exponents. So 1 right here plus -4, or you can think of it as 1 minus 4, that's going to be a -3. So we're going to have 3.21 times 10 to the -3 power. That would be our answer. So that was letter C in the practice test. Okay, let's keep going. 10 to the 0th power is 1. That's just something you kind of memorize. Length in the third dimension is volume. Okay, volume is length times width times height, 3 dimensions. So, yeah, measuring the length of something, the distance of something, you go in 3 dimensions, it's volume. That's really the only unit you have to worry about being in 3 dimensions. That wouldn't make sense for mass. There's no such thing as 3-dimensional mass. Mass is, how much oomph something has. Okay, the stuff. So yeah, length in 1 dimension is length, in 2 dimensions is area, in 3 dimensions is volume. Okay. All right, select which property of matter depends on gravity. Mass is the actual amount of stuff, the actual amount of like atoms you have, whereas weight is mass, but how much force you have from gravity pulling on it. So my favorite example is if I go to the moon, I'm still the same Josh. I still have the same mass, but my weight will decrease. So weight depends on what planet you're on, how much gravity is there, gravitational pull. All right, which property of matter does not change regardless of size? This is also known as an intensive property. Okay, I didn't get around to using this term intensive property in every lecture, so sorry about that. But all it means is to have a property that doesn't change no matter how big or small something gets. Okay, so density is the answer here. Let me go through the other ones. Mass. Is just how much stuff there is. So if you have something bigger, it's going to weigh more. Okay, it's going to have more mass, have more stuff. Okay, same with weight. Weight is the gravitational force. But yeah, if you have bigger thing, it's going to have more weight. Bigger thing, it's going to take up more space. And heat, this is kind of a weird one. If you have, 1 second. So you can just ignore heat here because heat is not really something that has to deal with size per se. Whereas if you make something bigger or smaller, that will affect mass, volume, and weight in obvious ways. Whereas heat, we're not talking about stuff. We're just talking about how much we're making things vibrate at the internal level. So the hotter something is, the more vibrations you have at the atomic level. So it's not an appropriate thing to talk about when we're talking about size. Whereas density is the answer here because density stays the same no matter what. If I have a small cup of water versus a huge swimming pool, water still has the same density. Okay. And you can use other examples besides water, like if we're talking about wood, okay, we're talking about the density of wood. Whether I have a small piece of wood on water or a huge boat, it's still going to float because wood fundamentally has a lower density compared to water. Okay, so that's what we mean by a so-called intensive property. Okay, so density, in summary, doesn't change no matter how big or small something is, whereas mass, volume, weight, if you get bigger, you have more mass, you have more weight, you have more volume. Those numbers will change. And then heat's not part of the discussion here, so you can ignore that option. Okay, 1 trillionth of a meter is 1 picometer. 10 to the minus 12 meters is 1 picometer. So then for the question, I asked kind of the opposite statement. how many picometers are in 1 meter? Okay. I can make an analogy with like centimeters. Oh, I wish I had a ruler on me, but if I had a ruler, then let's say I had a meter stick actually. So a meter is about 3 feet. It's a little more than 3 feet. It's like 3 1/3 feet approximately. But if I had a meter stick, there's 100 centimeters on it, right? So um, each part of the ruler is 1/100th of a meter. Okay, 1 centimeter is 1/100th, 10 to the minus 2 of a meter. But if I go the span of a whole meter, there's 100 of those little centimeters. Okay, so same thing here. If a picometer is 1/1,000,000th, ending in a th of a meter, then if I have 1 meter, that means I'm going to have 1,000,000,000,000 of those trillionths. How's that? Okay, so 10 to the 12, positive 12 picometers are going to be in 1 meter. You need a lot of the little thing to be equal to 1 of the bigger thing. All right, so that's the idea in that question. Okay, and that completes the multiple choice. Okay, for free response, for this table, I'm going to ask something similar to this on the exam. Basically, the exam will have all similar questions, except I just might change some of, the numbers here, maybe slightly different, word selection here, change the order. Yeah, I wouldn't have these same numbers here in like 1 through 5. I would just change them up. I will be honest, a few questions on the exam, I leave them exactly the same as the study guide, just to um, kind of reward people doing the study guide, and yeah, give some sense of familiarity. So that's my not so secret secret. All right, number 2, 1 inch is equal to 2.5, actually 2.54 centimeters. I draw an imaginary centimeter ruler below. Clearly mark on this centimeter ruler where 3 inches would be. So if 3 inches, if 1 inch is 2.54 centimeters, then 3 inches would be 3 times that. You can see me do a little bit of math here. So that would be 7.62, and I do my best to mark that in the ruler. I'm going to be pretty generous here. Because some people are not as comfortable with decimals as others. I know in the health sciences, they often teach, and just call an inch 2.5 centimeters. Don't even bother with the 4. So anyone on or close to this 7.5 here, I would give that full credit. Where I wouldn't give credit is if 3 inches, someone marks 3 centimeters to be 3 inches. That won't get credit. If someone's like too far off in this area or that area, I wouldn't give that credit either. But if someone's close to this 7.5 or to 7.6, I'm going to give full credit. I'm not going to nitpick on this first exam. Once we get more used to unit conversions, I will be more nitpicky about that. But for a first exam in the second week of the semester, I'm not going to nitpick that. Okay. We haven't talked about heat yet this semester. That'll come later. So I gave calories for you. Another measure of heat is joules. I just want to make sure people can come up with an example unit for any of these 5 things. If you gave me milligrams, kilograms, I don't care. That works. That's good. Instead of liters, you gave me milliliters. Okay. Density, there's other densities out there. Miles per hour, you could do kilometers an hour, miles per second, meters per second. I don't really care. Those are all valid speeds. Temperature here, I would accept Celsius, Fahrenheit, or Kelvin. Okay. Circle any measurements that are expressed as a ratio. The word ratio is kind of a blast from a past word. So let me remind you what a ratio is. It means something compared to something else. And in mathematical terms, you're going to see something divided by something else. Okay. So mass, no, it's just like grams, right? Length is just distance, volume. It's not a ratio because it's length, but in 3 dimensions. Okay. So liters, it's not like liters divided by something else. Okay, density is a ratio because it's mass divided by volume. It's mass compared to volume. Heat, calories, it's not a ratio. Temperature, it's not a ratio. Speed, it's miles per hour, meters per second. So it's something divided by something else. That is a ratio. All right, simplify the expression. I'll accept a regular number or a power of 10. Okay, so this sort of problem, my advice is to do it by hand on scratch paper and also type it into your calculator just to check your work. And the answer is 10 to the fourth power. If you got something other than 10 to the fourth power when you're doing it in your calculator, my advice would be to use parentheses in your calculator. Let me type that in the other screen. 1 second. Okay, let's see. We had 1, 0, -2, 4. Hang on. Yeah. Sorry, you might want to fast forward this. I'm not going to edit it out, so I can get this out as fast as possible to you all. Okay, 1, 0, -2, 4. I guess you're getting a free lesson in equation editor if you're actually watching me type all this. Okay, if I want to get really fancy, I could put these bullet operators, show multiplication going on. Yeah, that's good. Okay, and then what did I have in the denominator? 6 and -7. Okay, I copied that bullet operator, and then I'm pasting it there, so I don't have to keep going up there. Okay, so if you're typing this into your calculator, there's two ways you can go about this. The common way I see many students go is they'll kind of do a top answer divided by a bottom answer. Okay, let me decrease my font size here. You'll get a top answer, and then you get some bottom answer, top divided by bottom. Okay, so we can try that. Let's see, top answer would be 1 plus 0 minus 2 plus 4. Okay, so that's going to be 5 minus 2. That's 10 to the third power. Okay, let me do that one more time. 1 minus 2 is, I can ignore the 0. 1 minus 2 is -1, plus 4 is +3. Okay, good. And then for the bottom, it's going to be a 10 to the minus 1 power. Okay. If you have a negative exponent, if you bring it to the opposite side of the fraction, it'll become a positive exponent. Okay. Yeah, if you have a negative exponent on top, you can bring it down to the bottom as a positive exponent. If you have a negative exponent at the bottom, you can bring it to the top as a positive exponent. So this would be 10. Sorry, I'm not in my office where I have fancy graphic tools. So this would be 3 plus 1, 3 minus -1, whatever you want to call it. And of course, that's going to be 10 to the fourth power. I don't feel like writing a new line, so I'll just go like that. Okay, 10 to the fourth power. All right. So that's one way you can tackle the problem. The other is if you have a calculator that has parentheses, that's most scientific calculators nowadays. And you're going to type like one long line of text. I really recommend, oops, I did the wrong side, meant to do the denominator. For some people, they like to parenthesize, I'm making up a word, the top and the bottom. That's fine. You can't go wrong with that. If you're like, I forget which side to do parentheses, so I'm just going to do both. You could certainly do that. If you're a minimalist, the only part you need to put in parentheses is the bottom. Okay. Yeah, that's an option too. You put the bottom in parentheses so that it does orders of operations correctly in your calculator. In other words, this top answer, it'll know to divide it by 10 to the 6 and divide it by 10 to the negative 7. If you don't have these parentheses here and you type it into your calculator as one line of text, what's probably going to happen is your calculator is going to get the answer for all this top divided by 10 to the 6, and then it'll take the answer and do the wrong thing of multiplying by 10 to the minus 7. And we don't want to multiply it by 10 to the minus 7 because it's in the bottom of the fraction. It's in the denominator. Anyway, the answer is 10 to the 4th power. If you wrote something like 10,000, that's full credit because 10 to the 4th power is 10,000. If you wrote 1 times 10 to the 4th power, I don't care because that means the same thing as 10 to the 4th power. Anything multiplied by 1 is the same thing, right? Okay. All right. Lastly, we have these temperature problems. One of these questions I'm going to actually cut out on the exam because I can only have room for 5 problems. I'm going to cut out number 4 because I didn't use the word ratio in class. I mean, I'm sure many of you would get that problem correct, but I need to fit it down to 5. Okay. I'm going to see kind of your algebra skills and these temperature problems. You're expected to be able to do algebra to do temperature conversions. Okay. I provide formulas for now. For all your exams, I provide formulas, but for the final, they won't provide all of the formulas. They only provide a little bit. Most things you have to memorize. We can worry about that later. Okay. Getting 72 Fahrenheit into Celsius, you'd want to use either this equation. Oh, I'm not on the screen, aren't I? 1 second. Okay, now I am on the screen. Okay, so for 72 Fahrenheit into Celsius, you're going to want to use the equations that involve Fahrenheit or Celsius. So it's going to be one of these two equations. Okay. If you're not sure which equation to use, here's my weird advice. My weird advice is to use both equations, and then see which one makes more sense once you've plugged in your numbers. Okay, so in other words, 72 Fahrenheit. Okay, if you plug 72 into the Fahrenheit temperature here, you'll see that Celsius TC, temperature in Celsius, you don't have information for that. That means you're trying to solve for it, right? But we don't have TC by itself there. So I think if you plugged in 72 into TF on the left side, you would quickly see this equation is not so convenient. Okay. Again, if you're not sure, just try it. So then we go to this other equation. And again, we're dealing with Fahrenheit and Celsius, which means we're going to want to use an equation that has Celsius and Fahrenheit. Okay. TF means temperature in Fahrenheit. So I'm going to plug 72 into TF. I'm going to have 72 minus 32, 40. And then the answer of 40 divided by 1.8, that would give me the final answer. You put that in your calculator, it's 22. And you put degrees Celsius because the equation is looking for TC, temperature in Celsius. Okay, for letter B, convert 21 Celsius into kelvins. We want to look for something that has Celsius and kelvins in it. So that would only be the second two equations, because the first two equations have Fahrenheit in it, which we don't want. Okay. So I would put 21 into this equation. Again, if you put into this equation, this other one, it's fine, but you would end up with the same answer anyways. You'd have 21 here, and then you'd have to add 273 to both sides. So you're going to get the same answer as using this equation. So again, there's always a most convenient equation to use, but if you're getting confused, just use both equations, and then you'll figure out in hindsight which one was more convenient. Okay. So 21 plus 273 is 294. Okay. And as a bonus, okay, I'll leave this for you to figure out. No, I'll just tell you a strategy. 32 Fahrenheit into kelvins. You'll notice that none of these equations relate Fahrenheit to kelvins. Okay. So you have two options I can think of here. First option, this is probably what most of you would do, would be my guess. Maybe just half of you. But you would solve for the Celsius temperature first. Okay, you plug in 32 into this equation. 32 minus 32 is 0. 0 divided by 1.8 is still 0. And then we get an answer of 0 for the Celsius. Okay. And now that we have the Celsius temperature, we can plug it into this third equation here. 0 plus 273 is 273. Okay. So that would be our answer. Okay. So again, feed into one equation to get the answer, and then feed that answer into the next equation. Another thing you could do is, since Celsius is not part of the question, you could take this second equation that has Celsius isolated with respect to Fahrenheit, and then we have this other Celsius temperature isolated with respect to kelvins. So if you put the second and fourth equations equal to each other, you will eliminate that TC variable. Then you'll have to rearrange to get Fahrenheit by itself. I just thought of this. This would probably be even easier. We're aiming for the temperature in Kelvin, right? So we could take this equation here, that third equation, or excuse me, we could take the second equation and we could sub it into the third equation, and TC's right there. And then we can just go from there. And then the Kelvin's already isolated. I think that would be a little bit easier. But I'm leaving it bonus on purpose because I'm just kind of putting a higher degree of independence there. But if you didn't understand my explanation there, I think it was good. But if you didn't understand it, just email me or find me. Okay. I don't have it worth any points this time. Maybe I'll have it worth 1 or 2 points in the future. I don't know. But exam wrapper, just a chance to reflect on how the semester is going so far and how you felt about the exam. Okay. So that is exam one. Again, kind of half apology for it being the second week of the semester, but that sets up the rest of the semester really nicely so we can fit in 5 exams more comfortably, so that the week before finals week, we don't have an exam. Okay. That would be awesome. That's all I got. Email or find me for any questions. Thanks. Take care.